So we've introduced the concept of objects through this struct data type. But now I want to show off one of the key features of object-oriented languages, that is inheritance. And we can think about this in is-a versus has-a relationships. We can say that a rectangle has a length, and it has a width, and it has an area. But to say that a rectangle is a length, or that it is a width, does not make a lot of sense. In contrast, let's think about a square. Now, a square is a rectangle. So if we want to define a struct of a square, we would want to consider inheriting the properties of the rectangle. So let's create our square struct. We can say struct square, and then we will put a colon with rectangle. Having added this, our square struct now has access to all of the parameters and methods from rectangle. So we can already say that our square has a length, a width, and a way to calculate area. And I can demonstrate this. If I delete this one, I can say struct square s, and I can say s.length equals 5, and s.width equals 5, and then I can print s.area. And if I run this, we'll see that it prints 25. So now I've created another object that is a square, and I can say that this square is a particular kind of rectangle. And so since a square is a rectangle, I will inherit this rectangle in order to gain access to all of its properties. This, however, is a bit clunky. So you'll notice that by specifying the length and width, there's nothing that actually forces me to make the length and the width of a square exactly the same. I can set a square with a length of 5 and a width of 6, and this will run just fine, but it doesn't make a whole lot of sense. The point of a square is that its length is equal to its width. And in order to fix this, we're going to have to revisit our rectangle struct. And rather than setting length and width individually like this, what we're going to do is create a new member function called a constructor. Now, a constructor is a function that is called in an object as soon as it is instantiated. So by declaring this variable r as an object rectangle, the constructor function will automatically run. And we create a constructor by declaring a function with no return type that has the same name as the object itself. So we'll say rectangle, we'll put parentheses, and we'll open our curly brackets. And what we want is for the user to have to specify the length and width upon creating this rectangle object. And they'll pass an int length and int width. And in this constructor, we will set length equals L and width equals W. Now you'll notice that we have two errors appearing down here. So for the time being, I'm going to delete our square object, and let's edit our R object. So in this instance, rather than just declaring R generally, I want to put parentheses and specify its length and width. And let's print out R area. So when this program runs, we will create an instance of our rectangle structure named R with the parameters 4 and 5. So our constructor here, let me give some space, our constructor will be called, and we will set our member variable length to our first parameter and our member variable width to the second parameter. So when we calculate area, it should print 20. And there we go. So by using this constructor method, we can force the user to provide the length and the width upon creation of the object. So let's take a look at square again. Rather than having nothing in its curly brackets, let's define a constructor. We'll say square. And for a square, we only need one parameter, that is its length, because its length and width are equal. And this constructor needs to call the constructor of rectangle, and it will pass as the length and the width its length. So it'll pass L twice. We'll open our curly brackets, and now that's going to do nothing. So now if I create an instance of square, name it S, and it will have a length and width of 5, and now let's print s.area. And it should give us 25. So by using inheritance, we are able to gain all of the parameters and functions that exist in the parent object. And by using constructors, we can force the user to give us input to these objects upon creation. And that allows us to make a square that has the exact same length and width with a very small amount of code. So if this video was useful for you, please leave a like. It helps me grow the channel and it will help other people find the video. And again, if you would like to see these tools used in a broader context, I recommend checking out my Developer Diary series, where I am working long-term on big projects and actually putting these tools to use. So thank you for watching. I hope you learned something, and I will see you in the next one.